In this video, we will explore NFL field goals. In particular, the relationship between field goal percentage made and the distance of the kick. In order to do this, we will use the NA Omit function in R, which allows us to address cases where there is missing data. We will also use the Histogram and Boxplot functions to visualize the distribution of the data. Then we will also combine data to create some summary visualizations using the plot and line function. So in particular, the case that we're exploring is the relationship between the distance of the kick and the percentage of time the kick is successful. So the hypothesis, which you may recall from a previous video on the scientific process, is that we're exploring the relationship between the distance, which we say has an effect on the field goal percentage. So as distance increases, we are suggesting that the success rate decreases. So in the XY coordinate, this can be modeled as distance on the x-axis and field goal percentage on the y-axis. Now the question is, if all these data were plotted, what would the relationship look like? This is in particular what we're going to explore. Now, in order to understand what a field goal looks like, I wanted to just draw some lines to demonstrate when I refer to a field goal that happens between 0 and 20 yards, it's somewhere within this range. How many times does it go in? Then a field goal between 20 and 29 yards, we're going to look at that data separately. 30 and 39 yards, and finally, any field goal that is 50 yards or more, how many times does it go in? We're going to explore data from NFL kickers from one season, and we are going to hold constant the same players. In other words, we're not going to compare those players across seasons or to other players. Those players that are in our data set are going to be the only ones that we compare, and that happens within one season. And what we're going to vary is the distance from which the kick is being made. And the data are split into 5 groups: 0 to 19, 20 to 29, 30 to 39, 40 to 49, and finally anything greater than 50 yards. So what I've done is created a short program in R, which I will walk you through now. The first step in doing the analysis requires importing the data set. We will do this by clicking on Import Data Set from Excel. Now, what I have here is my Excel file already set to go. We're going to use field goal data NFL NV2. So as soon as we load it, you'll see that we have the player names, the teams that they belong to. This is field goals made versus field goals attempted, and then this is the percentage of made divided by attempted. You'll notice that in the first case, Justin Tucker made 97.4% of his field goals. This doesn't actually tell us how good he is from different distances, so we are going to dig into the data a little farther. The next 5 columns are what we're going to focus on. FG019 is field goals made between 0 and 19 yards. You'll notice that all of the NFL kickers made it 100% of the time. That's a short and easy field goal to make. FG 2029, however, you'll see that not all kickers were 100% successful. And as you go farther and farther from the goal line, this makes it an even more difficult kick. You'll see that the percentages vary significantly from 0 to 100%. What I want to point out, and this is the first challenge of dealing with missing data, is in the case where the field goal kicker did not kick a short kick, we have NA for not applicable. Now that's more appropriate to use than the number 0, because if there was a 0 there, then it would essentially say that that kicker missed that kick, but that was not the case. That type of kick, or a kick from that distance, was never attempted. So you'll notice that there are a lot of NAs in this column. And so what we're going to focus on is how to handle those situations. Okay, we'll click Import, and you'll notice that on the top right we have 36 observations of 13 variables. Essentially what this means is there are 36 unique players, and we have 13 different data columns in order to consider this data across 13 different columns. Okay, let's go back to our code now that we have the data loaded, and you can view the data again with this view command. We've already done that by loading the data. It automatically displays it. So the first thing we're going to do is we're going to create a new variable. This variable is going to be called FG019. And basically what this allows us to do is extract the data from the column, field goals 0 to 19 yards. And remember, we use the $sign to explicitly refer to that column. And we're extracting this column from this data file, field goal data NFL NV2. So we're going to run that command. Okay, now you'll see on the top right there are 1 to 36 entries. Many of them are NA. In other words, that distance of a field goal was never attempted. So it would be inadequate to enter a 0 in place of NA. So instead, this is the extra step, is we need to create a new variable that will omit the missing data. So let's create a new variable called FG019 kicks, and that variable will be comprised of, here's the function, na.omit FG019, which is the variable that we created previously, which was an extraction of this data. So let's run that command, and the first thing you should notice is that there are only 9 data points in here. You'll notice that all of them are 100, which makes perfect sense. Let's go back to our data. Only 100 exist as data points in this column, and only 9 kickers. If we scroll down, there are 9 kickers who attempted field goals of 0 to 19 yards. So instead of going back to my data file like I did by clicking on this tab, I could also type the command view FG19 kicks, and it will only display the 9 data points that exist. Now let's handle the data for field goals made from 20 to 29 yards. So we will create a variable called FG2029, which is extracting here the column, $FG2029 means the column labeled this, from this data file, the field goal data NFL NV2. You'll notice on the right there are 36 entries, just like in the previous case, and we will, just to be safe, omit any missing data by using the same function as before, na omit FG2029. Let's run that line, and you'll notice that the length of this vector is 1 less than the original variable. In other words, we only have 35 data points instead of 36. Well, let's find out why. Let's run the next line, which is view 2029 kicks. Okay, 35 data points, no missing data. If we look at the original data file for FG 2029, you'll notice that the last player, Patrick Murray, did not attempt any field goals between 20 and 29 yards. Therefore, there is the NA for him. So by running the omit function, we were able to only consider players, the 35 out of the 36 players who did have attempts from that distance. Okay, now one of the things that I'm going to do for this data set, which I did not do for the 0 to 19 yard kicks, is I'm going to create a histogram. Now I didn't do it for the previous one because all the data points were at 100%. See, everybody made field goals that short. So a histogram wouldn't tell me any information that would be useful. But from 20 to 29 yards, there are values other than 100%. So let's run that, that command, and you'll see that this histogram gives us an idea that the majority of the kickers are 100% successful. There are a few misses, though. So that's interesting to note. We're going to come back to this and compare it to kicks from different distances. Okay, now let's proceed and analyze data from the column between 30 and 39 yards. So let's create a new variable called FG3039, which is looking only at the column FG3039 from this data sheet. You'll notice that it's now, I ran that line, which means it created a new variable up here, and it has 36 entries. Okay? Now let's run the omit function again, and you'll notice that the length of this variable is also 36, meaning that it is identical to the previous variable, telling me that there are no missing data points. So let's run the view, let's view that variable, FG3039 kicks. And you'll notice that there are 36 variables, and all of them have data between 0 and 100%. Okay, now let's view a histogram of that data, and it's going to overwrite the one that I previously drew on the right. And look at the shape of that histogram. So you'll notice that the distribution is a little bit different. There are a large number of kickers who are 100% successful, but then there are some that are less than 100% successful. Okay, so that's already telling us that there are some harder. It is much harder to make kicks from a longer distance. Now, what I want to point out is that in this example, I'm only analyzing data for the first three columns: 0 to 19 yards, 20 to 29 yards, and 30 to 39 yards. Now what I'm going to do is I'm going to add this fourth column by replicating the code from the previous three, and that's going to give me a fourth dimension to my data. Okay? So the easiest way to do this, because the code for 30 to 39 has already been written, is I'm going to copy those lines and I'm going to paste them right below. Okay? So instead of having to type everything from scratch, I'm going to modify the code for a very similar variable. So the first thing that I want to do is I want to create a variable, a new variable called FG40 to 49 from the column % field goals made from 40 to 49 yards. So the new variable is going to be called FG4049, and it's going to come from this data sheet, field goal data NFL NV2, and it's going to be, it's the column called FG4049. Okay, so let's run that line since I've already completed it. Okay, you'll notice that there are 36 samples there. Now the next line, we're going to create a new variable called FG4049 kicks that omits missing data. So FG4049. Notice it's very simple. I'm really just changing one variable. Instead, I'm replacing all the 3s with 4s. Let's run that line. Okay, so this also tells me that there was one player who did not attempt a kick between 40 and 49 yards. Okay, now I'm going to double check that missing data are omitted. Let's change all the 3s to 4s. And view that data. Great, I see that column and it's all numbers between 0 and 100. That's great. And I'm just going to go back to my original data file, and because I'm working with 4049, I'm curious who the missing data is from. Again, Patrick Murray. Well, he didn't have many kicks. So he did not kick a field goal between 40 and 49 yards long, which is fine. You'll notice that he did kick a field goal of 50 yards, and he was unsuccessful, so that's why it's a 0 in that case. But again, we're only working with this column, field goal 40 to 49. The last item, or that's last row we want to edit, is this one that creates a histogram. So we're going to create a histogram of field goal percentage made from 40 to 49. Again, I'm just changing the 3s to 4s. And the histogram is of the variable that I created before, FG40 to 49 kicks. Now let's run that, and it's going to overwrite my histogram. You'll see, here we go. So the data keeps getting more and more spread out, meaning that it becomes more difficult to kick field goals that are farther away from each other. We already are seeing that trend. Now let's look at box plots. Box plots are a way to see how the data are distributed. It's similar to a histogram. A histogram displays the data across the horizon, so a horizontal histogram, whereas a box plot flips the data into the vertical scale. So you'll see, for instance, if we do a box plot of FG019 kicks, again, this is all the kicks between 0 and 19 yards, omitting missing data. So this variable only had, see, 9 data points. Let's do a histogram of that. You'll notice that it's a flat line because all the data points are 100. Okay, so that the histogram doesn't actually tell us any new information. It just says, hey, all your data points are 100. Great. Let's do a box plot of FG2029 and see what that looks like. Now, you'll see that the horizontal line, which actually represents the mean, is very close to 100, and then there are a couple of data points that trickle down over here. Okay. Now this particular variable, FG2029 kicks, had 35 entries, most of them at 100%. Okay, finally, let's do a box plot of 39 kicks, and you'll start seeing that the data points are even more spread out. So the box plot allows us to see the data in quartiles, meaning increments of 25%. So this solid horizontal line, this is the mean of the data, okay, which is around, looks like it's around 97%. So the average success rate for field goals of 30 to 39 yards is around 97%, but there are people who are less successful, so that's what this tells us. Okay, and let's finally do one more box plot, which we are going to create here, and that is the box plot of FG4049 kicks. And let's run that. And even more interesting, you'll see that the horizontal line, the mean, is below 80%, but most of the data is very close to 80%. There are a few people who are unsuccessful or very low success. Okay, Now what we're going to do is we have the variables, but we want to collapse them into a single number, which is the mean. So we're going to calculate the mean of the field goal percentages for all the distance evaluated so far. So we're going to create a new variable called FG019 kicks M. And so that letter M indicates that it is the mean of that data. So that is equal to mean, which is the function in R, mean of the variable called FG019 kicks. And again, that variable is only the cases where there is data. So it omits missing data. So I'm doing that I'm going to add one more, which is the fourth distance that I'm considering, FG4049 kicks, and the new variable has an M at the end, and that equals mean FG4049 kicks. So let's run all these four together. So by highlighting all those rows, I'm going to hit run, and you'll see that it ran all four, and then the results are displayed here. So the mean of 0 to 19 is 100. Yeah, well, all those data points were 100, so that's why the mean is 100. The mean for 2029 is 97. The mean for 3039 is 92. And finally, the mean for 4049 is 79%. So you'll see how the mean success rate is decreasing as distance increases. Okay, so moving along here, a couple of more steps. We're going to create a new variable called FGM, so field goal mean. And what the field goal mean variable is going to comprise of is a combination of the variables that we have considered. So we've only considered the first four: 0 to 19, 20 to 29, 30 to 39, and 40 to 49. Let me add a fourth item here, which is FG4049 kicks mean. Okay, so now this is a four item combination, new variable called FGM. Let's run this. So there are four items: 100, 97.6, 92.9, and 79.4. Now FGM is, I created this variable because I'm going to use that to plot these data. Okay, before I create the plot, I now need to create one more variable, which is my labels. So the label is FG_dist for FG distance, field goal distance. It's a combination of 19, 29, 39, and finally let me create one more called 49, quotes 49. I'm going to run that command and make sure that it is length of 4 characters. Okay, so you'll notice that FGM is a variable that has 4 numbers, while FG_dist is one that has 4 characters. Okay, it's treating these as characters by putting quotation marks around it. Okay, now we're ready to create a plot, and what we're creating the plot of is FG_dist on the x-axis, which are the distances of the field goals, and then FGM, which are the means of the field goal, on the y-axis. Let's run that. And here is my plot. So you'll see that as distance increases, as x increases, percent success, or the mean percent success, decreases. And here it is evident. Let's now connect the dots. So I'm going to actually add some labels first. The labels are going to say relationship between field goal, distance, and success, and then I'm going to add some labels for x and y. Okay. Finally, the last row in this code is adding a line that connects my x variables, FG_dist, and my y variables, FGM, and I'm just going to add an L, which is a type of line. There are different types of lines, but this one is just the very simplest one called L. So by running this, it's going to connect those dots. Now, from this visualization, it is evident that as yards of the attempt increase, success rate decreases. Now, your task will be to add the fifth missing distance, which is called FG50. Okay, now you'll notice that there are no missing variables. Okay, that means that everybody in this data set attempted a 50-yard field goal. However, you have to go back to the code and replicate what was done before in terms of creating a new variable, making sure there are no data that need to be omitted, and then creating a histogram of the data. So these 4 lines need to be replicated for FG50. You need to add a box plot here for FG50. You need to create or calculate the mean and create a new variable called FG50 kicks M. And then FG50 kicks M needs to be added here so that it is accounted for in this combined variable. And then the label 50 needs to be added here so that that distance is also included in the plot. So that is your task, is to add the fifth distance to be able to see if the trend continues in this direction in terms of the difficulty of field goal kicks as a function of distance.